Hey there, welcome back to Go Figure. Today we are on lesson 50 of Saxon Algebra Half. Today we are going to learn about scientific notation for numbers greater than 10 and scientific notation for numbers between 0 and 1. Please like and subscribe to the channel. Thanks. Here are some quick warm-ups. Let's just do them together because they are so easy. Here we have 10 to the third. Remember, 10 to the third is telling us to use 10 as a factor 3 times. So 10 times 10 times 10, which equals 1,000. And notice how the number of zeros we have in this number is the same as what our exponent was. So 3 zeros when we're going to 10 to the third. So 10 to the fifth then would be a 1 with 5 zeros behind it. I got a comma there. There we go. So that'll be 100,000. And notice 1, 2, 3, 4, 5 zeros behind a 1. And then 10 to the sixth would be a 1 with 6 zeros. So that is a million. And you'll see how that's going to come in handy as we're doing our scientific notation today. Our learning objectives are to write scientific notation for numbers greater than 10 and also to write scientific notation for numbers between 0 and 1. So starting with numbers greater than 10. Just a quick sort of review. So here we have a decimal number and we're multiplying it by 1,000. When we multiply a number by 1,000, we can move our decimal point the same amount of number of zeros that we have to the right. So if I move that 1, 2, 3, that puts our decimal point between the 7 and 1, so we get 47.1. And as we just saw how 1,000 is the same as 10 to the third, we can rewrite this top equation, rewrite it as this decimal times 10 to the third, and the answer is of course the same. 10 to the third is just a shorthand way of writing 1,000. So when multiplying a number by a positive power of 10, we just need to move the decimal point to the right, the number of places indicated by the exponent. Right, so if you have you're multiplying a number by 10 to the third, you need to move that decimal point 3 places to the right. And we can use this fact to write very large numbers in scientific notation. So here are the steps to follow as we're writing scientific notation, and then we'll go into a couple examples. So the first step is to place the decimal point just to the right of the first non-zero digit. Second step is to count the number of places that the decimal point moved to the left. And then lastly, we would multiply the number that we got from step 1 by 10 to the b power, where b is the number of places the decimal point moved. So this might sound like a lot of, a little complicated maybe, but let's look at an example and see how to do this. So here we have kind of a big number and we want to write it in scientific notation. So the first thing we want to do is we want to put our decimal point behind the first non-zero digit in this number. So the first non-zero digit here is 8. So I'm going to rewrite this as 8.055. And I can stop. I don't need to include the next zeros because obviously that number would be the same. So we'll just write it as 8.055. And then we want to multiply it by a power of 10. And the exponent that we use is how many spaces spaces that we move this decimal point. So originally the decimal point was here, right behind these 2 zeros. We just don't write it because it's not necessary. But to get it to to get the number to be 8.005, we move that decimal place 1, 2, 3, 4, 5 positions. So that tells us what our exponent is going to be. So we have that number times 10 to the 5th. And if you think about this, 10 to the 5th, we know, is the same as 100,000, right? So this is the scientific notation form of that number, but what it's saying is 8.055 times 100,000, and that would give us this original number that we started with. All right, here's another example. We want to write 371.89 in scientific notation. So again, we want to start with our number having a decimal point behind the first non-zero digit. So 3 point, and then we'll write the rest of these digits, 7189. And then we need to multiply by 10. And the power that we're multiplying it by is how many spaces we moved our decimal point. That was 1, 2, 2 spots. So 10 to the second power. And that is scientific notation for this number. So you always want to have the number that you start with should always be between 1 and 10, right? It's only a single digit here before our decimal point. All right, so now we'll move on to numbers between 0 and 1, writing them in scientific notation. So just like we used positive exponents, we can use negative exponents to write numbers between 0 and 1 into scientific notation. And the steps for that are to place the decimal point just to the right of the first non-zero digit. So that's the same step as what we did with numbers greater than 10. And then we would count the number of places that the decimal point moved to the right. And lastly, we would multiply the number in step 1 by 10 to the negative b power, where b is the number of places that the decimal point moved. So let's look at an example of that. So here we have a number that is somewhere between 0 and 1. And so to write this in scientific notation, we need to put our decimal point behind the first non-zero number in this non-zero digit in this number. So that would be 5. So we're going to make it 5, then our decimal point, and then the rest of the digits, 21, 5.21. Then we're multiplying it by 10, and then the power is going to be negative. And how many places did we move that decimal point? 1, 2. This is going to be 10 to the negative 2 power. All right, here are a bunch of practice problems to try on your own. Pause the video and find your answers to these, and then press start when you're ready to check your answers. All right, write each of these numbers in scientific notation. So our first one, 476,000. So we want to first get one digit in front of our decimal point, and we'll put the rest of our digits behind it. Then we want to multiply it by a power of 10. And in this case, we're going to have a positive number. And we moved our decimal point from here, 1, 2, 3, 4, 5 places to get to 4.76. So 4.76 times 10 to the 5th power. Okay, here we have a number between 0 and 1, so we're going to need to use negative power of 10. So again, we're going to start with putting our decimal point behind the first non-zero digit, so 4.76, and then multiply by 10, and then how many spots did we move our decimal point? 1, 2, 3, 4. So that's going to be 10 to the negative fourth power. Okay, here we want one digit in front of our decimal point, and then we're going to write the rest of them. So don't forget this 0, 56, 3.056 times 10. And then how many places did we move our decimal point to the right? It can help to use these commas. So 3, 6, 7. So 10 to the 7th power. Okay, and this one, our first non-zero digit is 3.056. This number is between 0 and 1, so we're going to use a negative exponent. So times 10, how many places did we move our decimal point? 1, 2, 3, 4, 5, 6. So 10 to the negative 6 power. All right, so here we're given the scientific notation, and we need to write it into standard form. So I can write 406, and we are moving the decimal point 5 spaces because it's multiplying 10 to the 5th. So to move this 5 spaces, we have 1, 2, and then need to add 3 more zeros here. So 1, 2, 3. Put our comma in there, and you can always check that by kind of going in reverse. So our decimal point is here now. If I go 5 places back, 1, 2, 3, 4, 5 to get 4.06. Okay, and here we have a negative exponent. So to put this into standard form, this is what I like to do for these ones. So we need to move our decimal point 6 places to the left. So here it started behind the 4, so now we're moving 1, 2, 3, 4, 5, 6, and then our decimal point. And what I like to do actually, because when we write decimals, we should always have a 0 in the ones place. And if we do that, we can count how many zeros total we have. We have 1, 2, 3, 4, 5, 6. We have 6 zeros before our non-zero digits start. And notice that was what exponent we had, negative 6. So like, let's say this was 4.72 times 10 to the negative 4th. An easy way to start this would be to write 0 and then our decimal point and count how many zeros that we're making. So we already made 1, 2, 3, 4 because we have 4 as our power, and then do your digits 4, 7, 2. And that would be the same thing as if we counted the other direction. If our decimal point is here after the 4, move 4 spaces, 1, 2, 3, 4. That gets it right to where it needs to be. All right, so just to review the scientific notation format, we always want to have a number between 1 and 10 multiplied by a positive or negative power of 10. And that's all for today. So you can do problem set 50 and then read lesson 51 in your textbook. Like and subscribe, and I'll see you next time.